now let's talk a little bit about balancing these type of reactions. We're going to use what's called the half reaction method, which is where we separate the oxidation-reduction reactions into the two parts. We look at the oxidation part and then the reduction reaction. So if we look at this example, the oxidation reaction is the aluminum part, because here it's the neutral element, and then as the product we know monotomically iodine would be a 1-, so it gives it a -1, making aluminum a +3. So it was oxidized, it lost electrons. That means that the iodine part must be the reduction part then. Here we've got iodine as 0, because it's the neutral elemental form, and it went to a -1 or a 1- charge, and so it was reduced, or is the oxidizing agent. This could differ a little bit depending on whether the reaction takes place in acidic or basic solution, and we'll look at an example of each. Okay, so for balancing in an acidic solution, you're going to write the separate reactions. For each half reaction, you need to do 4 steps. First, you balance all the elements except hydrogen and oxygen, and sometimes you won't have to do all 4 steps for each half reaction. Then you're going to balance the oxygen using water, so you would add 1 water for each oxygen present. Then you're going to balance the hydrogens using the H+ ion, and then you're going to balance the charge using electrons. And this may sound a little foreign, and we're going to go over some examples. Once you've done that with each half reaction, then you're going to multiply by whatever integer is necessary to equalize the number of electrons transferred in both half reactions, because that has to be the same. Because remember, that's the whole idea of redox reaction, is transfer of electrons. Once you've done that, then you're going to add the half reactions together, cancel out identical species, and that will give you your balanced reaction. And then you can always double check, make sure all your elements and charges are balanced, which is what you should do. So let's look at an example of this. Whoops. Okay, so first thing that I want to do is assign oxidation states to everything. I know oxygen is always a -2, because there's 4 that makes -8, but this is an ion, so it's an overall 1- charge, so that makes manganese a +7 oxidation state. Iron is the monatomic ion. Its charge is 2+, so that makes its oxidation state +2. Here iron is a monatomic ion with a 3+ charge, so that makes its oxidation state +3. And here manganese is a 2+, and so that makes its oxidation state +2. So now I want to determine my oxidation and my reduction. So let's look at our Mn first. We went from +7 to +2. So to me, that looks like it was reduced. And so I'm going to say that manganese was reduced, which makes it the oxidizing agent. So now if we look at our iron, it went from a +2 to a +3. So it was oxidized, making it the reducing agent. So let's write our reduction reaction first. So we have MnO4-. I'm going to leave a little space in case we need to add anything. And then we're going to Mn2+. So I'm splitting up my 2 reactions. Let's do this one first, then we'll go to the iron or the oxidation part. Okay, first thing we need to do is balance everything except oxygen and hydrogen. I have 1 manganese, I am all set. Then I need to balance oxygen using water. Well, here I have 4, and so what that means is on this side I want to add 4 waters. So I also just added some hydrogens. Balance hydrogen, I need to add the H+ ion. I have 8 hydrogens, so I'm going to add 8 H+. Now I need to balance my charges. Well, here I have a 1- and 8+. That gives me a total of a 7+ charge. Here I have a 2+ and neutral, so I have a 2+ overall. So that means on this side I want to add 5 electrons to make the charges the same on both sides. So I'm going to leave that one alone for a second and go to my oxidation reaction, which is the iron. So here I had Fe2+. I'm going to leave some space and go to my Fe3+. Well, my ions are balanced. I have no oxygen, I have no hydrogen, so the last thing to do is balance the charges with electrons. Here I have 2+, here I have 3+, so I need to add 1 electron. So now, before I can add these together, I need to equalize the charges, which means I need to multiply my oxidation reaction by 5 in order to have 5 electrons to match up with the 5 electrons in my reduction reaction. So I'm going to multiply everything through by 5. Now I'm ready to add things together. Since I have 5 electrons on both sides, those are going to cancel. And now I can write everything else down. So MnO4 plus my 8 H plus and my 5 iron ions. And that's going to go to my manganese ion, my 4 water, and my 5 iron 3 ions. And if I do a quick check, everything should be balanced out, and it looks like it is, and the charges should be balanced as well. So that's it. When you have a basic solution, there's one additional step. So you're going to use the previous half reaction method to balance as if H plus ions were present. And then your final step is to both sides of the equation, you want to add however some number of OH minus ions that's equal to the number of H plus ions. So, it's basic now, so you're neutralizing some of those H pluses. If you have a side that contains H plus and OH minus ions, then you can form those into water. And then if you've got water molecules on both sides, you can cancel those out. And then again, make sure to check that everything is balanced. Okay, so again, let's go through and first assign oxidation numbers. So I know silver is a 0 because it's in its elemental form. If this broke apart into my atomic ions, nitrogen would be -3, making carbon a +4 because the overall ion is a 1-. Oxygen in its elemental state is 0. So now here I know that this overall ion charge is a 1-. There's 2 of them, which makes it a 2-. Overall, I want the overall charge to be 1-, so that makes silver a +1. And then these, because they're in the ion, aren't going to change. -3, +4. And now you notice we don't have oxygen over here, and that's okay. We're going to take care of that in a minute. So let's look at the silver. We went from 0 to +1, so it was oxidized, or it's the reducing agent. Now carbon and nitrogen did not change oxidation state, so the only thing left is our oxygen. So we went from 0 to something. Well, let's assume that it's going to get reduced, because usually oxygen, when bonded with other things, has a -2 oxidation state, so that would fit, making it the reducing agent. So let's look at our silver reaction first. Now I need to include the cyanide ion because it's bonded with the silver on the product side. I'm going to leave some room to add some other things. Okay, so let's take care of this one first. We want to balance everything except oxygen and hydrogen first. Silver looks okay. I've got 2 cyanide ions, so I need a 2 out front here. I have no oxygen present, no hydrogen present. The last thing I need to do is balance the charges. Well, this is 0. Here I have a 2- charge. And here, because this entire ion is a 1-, I need to add 1 electron to this side to get my charges to be the same on both sides. So now let's look at the oxygen reaction. I've got O2, and then I don't have a product on that side. That's what's going to happen when I balance my oxygen and hydrogens. So I have no other elements except oxygen and hydrogen. So in order to balance oxygen, I need to add water. So I'm going to add 2 waters. Now remember, for every hydrogen I have to add an H plus ion. So over here I'm going to add 4 H pluses. Now if this was an acidic solution, I would then go on to do the charges and add everything together. But because this is basic, I need to add OH ions to both sides for every H plus that exists. So because I have 4 H pluses, I need to add 4 OH minus ions on both sides of the reaction. Now this will form then into 4 water molecules. So now I can do charges. On this side my overall charge is 0 because these went together to make water. This is 0. And on this side I have a 4- charge. So that means that I need to add 4 electrons in order to make everything neutral. So then what I need to do is, before I can add both equations together, I need my electrons to be the same, which means I need to multiply my top equation by 4 in order to make this 4 electrons to balance with this 4 electrons. So 4, that's going to make that an 8. This is 4, and this is 4. Now if you wanted to rewrite the equation down below, instead of crossing numbers out, you totally could do that as well. Okay, so now I'm ready to add everything together. My 4 electrons are going to cancel on both sides. I've also, let's see, got some water on both sides that I can cancel. I have 4 on the right, 2 on the left, so the 2 are going to totally disappear, leaving 2 on the right side. So now let's start adding together. I have my 4 silvers plus 8 cyanide ions plus my oxygen and the 2 waters. That's going to go to my 4 silver cyanide. Oh, I'm running out of room. And let's see, what else do I have left? Just the 4 OH minus ions. Okay, make sure that you do a quick check that everything is balanced and that all your charges are balanced. Looks to me like we're good. Okay, so that's how you would balance for basic.